Oftentimes, when it comes to testing, software development, especially built-in quality, I'm asked very often, what are the KPIs or what are the metrics? A lot of times the things we have as KPIs are not really helpful. They do indicate the direction something's headed, but knowing that doesn't really improve the situation or especially the quality of the product. If you look at Edwards Deming's list of 14 points, one of them, I think it's number 3, talks about stopping dependence on mass inspection. In manufacturing, they were building a car and then having mass inspection afterwards to make sure they got it right, instead of building the quality in to begin with. And his point always was, if the way you go about building the car is done in a quality way, you're going to end up with a quality product. Same thing with software. Our whole industry, the definition of how to do things well seems to be develop the software and then do mass testing afterwards. And then we're trying to do the mass testing better. That's where a lot of test automation is right now. It's automating the inspection of the software, thinking we're doing things better. We're not. We're in some ways, we're making things worse. Got more overhead and more cost and time sunk into trying to automate what we shouldn't even be doing in the first place. It's just costing us far more than it's worth. So when I refer to the key measurements, the KPIs or the metrics, and those things that really aren't worth measuring and those that are, that's my mindset. I want to measure the things that have to do with the quality, specifically the quality of what we are even doing, making sure it's having value. Those practices, those principles, those patterns that we know result in better quality of development and delivery, but better quality of product. Those principles, practices, and patterns are what we are looking at to say, how well are we doing in those things? And that will result in a better product. Before we get into what those are, let's talk a little bit about what normally is considered good KPIs or metrics today. So as I go through this grouping, my opinion is, from what I'm seeing, we tend to measure one of two things. We tend to measure activity, and we tend to measure failure. And those are the metrics we use to try to do better. What we're not doing a very good job of is measuring those things which are indicators of success so that we can improve on them. We can focus on getting that number to be better, a bigger number. Instead, we keep trying to measure things that we're trying to reduce and get rid of. So in general, they kind of get grouped that way. So I'll kind of go through them in that way. Cost of one of the things we look at is cost of reported defects. And so we're looking at things like severity and priority and status of different defects that come in. How many are closed, deferred, rejected, some companies call it. How many are being investigated? We're focusing in on looking at defects. Well, defects are the things we don't want, but yet that's what we're focusing on for key measurements. Another thing they look at is defect density or resolution time and leakage. Leakage is probably the only one that I say is something we should look at, but when you get very good at built-in quality, as getting all the things in place that truly build quality in, you'll find that you will measure leakage in a different way. The other cost that we tend to put metrics around is the cost of inspection. We look at the design and development of testing, when they're authored, which ones are automated. We try to make sure that when we're authoring them, we're covering all the requirements and we're covering all the code. So this has to do with when we're developing and designing tests. We look at the cost of that. We look at the cost of execution, number of tests executed, the time to execute them, the number of executions. We're focused on on the tests themselves, how many we're executing and what that looks like. And that's a cost of inspection, if you will. Effectiveness, what's pass fail, how many are automated, how many are manual, how many defects are found by the different tests. We're looking at the cost of inspecting the software, when again, we probably shouldn't be inspecting the software in the first place, or at least reduce the inspection. There's some inspection you do need, but we have most of our costs right now in inspection and very little in really using testing to build quality in the first place. One more thing before I get to my list of metrics that I would recommend is to cover a couple things that if a company does these, they will almost immediately experience an improvement in life at their company. The groups, the teams will begin to improve how they're developing and delivering the software just by a couple of I say simple. They're difficult because we have to break paradigms, but they are very simple things. One way to do that is to set the expectations that you have for development and set them as if built-in quality is in place, as if we are already there. So here's the way things should look. Here's what we want to measure. Set that expectation and then empower and enable your teams to deliver on that. So they're going to run into impediments that have to do with other teams, other systems, other things they don't have control over. That's where, as leaders, you may need to sit down with other leaders in the organization and say, look, we need to figure out a different way to solve what you're solving here because it is costing us too much money. And put that down, show the cost. You have your people help you with that, show the cost. Doing that is an example, an observable example to your people that you're behind them. You're not just setting this new expectation on them. You're going out there and clearing the way for them. And I also recommend not delegating that. Don't have one of them do it or bring in an assistant or something like that. Just like I've heard in World War II, when you had those leaders, those people that didn't need to be out on the battlefield, who did get out there and charge out in front of their men, that inspired and motivated their men and just caused a lot of fast and very successful action and activity. Same thing here. I have seen that when leaders, even at the highest level, really step out front in a very visual way for their people, that they're going out and they're not only committed to setting the bar for their people, they're going to go out there and make it achievable. That is very inspiring to your organization. It will help quite a bit. So that's one thing. Again, it's simple. I know there's complications, but it's simple. Just make the commitment. Very effective. By the way, that will also lead to things like considering environment constraints, security approaches that have been put in place that are hamstringing, efficient and effective testing, infrastructure type impediments that may be in place. So it'll expose those because you have set that expectation. Your team will come back and say, look, we'd love to do that, but we can't because of X. And that gives you an opportunity to charge out there and start getting conversations going and getting some innovation around those impediments. And then another thing is to reconsider our definition of a defect. Now, back in the day when I started, and it's very common today, we considered anything that where a requirement that was set was not met to be a defect. Anything where there was a requirement one day and the system isn't doing that, and that's a defect. And we would submit those, and we'd have a long list of defects, and we'd put them into the defect tracking system, and then we'd have to triage those because, if we don't, then we're going to have this long list of open defects that never get touched. So we need to triage them to decide which ones get deferred and which ones are going to get addressed. If they are going to get addressed, when and how, with what people, which ones need more investigation. I mean, it was a major issue triaging these defects. And it was not uncommon for us to look at one from like 2 years ago and think, is that feature even there anymore? And then we got to spend time, somebody has to spend time to find out, is that feature even there anymore? Does a defect even exist? Triaging defects is a massive time sink. And I gave some thought one time to what is a defect. I said, okay, let me get rid of that definition for now. I might come back to it. I might, discover that, yeah, that is the right definition. But let me try to rethink what I would consider a defect. And I came up with 2 questions that I ask now of any issue that's identified. Doesn't matter what it is. First question is, would this issue block acceptance of a current user story? I asked the product owner, would this stop you from accepting a user story that we're currently working on? And if they say yes, then we fix it right away. I just turn to the developer and say, hey, go ahead and fix that. Why write a report about something that we discovered during the development process? If you think about it, when the developer's typing, he might do a syntax error. Are we going to write a bug for that before he backspaces and retypes the right word? No, he just fix it. And so we could do the same thing here. The only time that I see it valuable to write a defect report is if we can't get to it now, and whoever gets to it later is going to need some kind of information. Other than that, we don't need to track these. Just get it fixed. My second question is, would this block release of this build to production for some reason? And if the question is yes, again, we just fix it. Talk to whoever needs to do it and get it done. If we do need some type of reporting, okay, we'll put together a bug report if the person can't get to it. We'll put together a defect report to get them the details. But if the person's right there or can be communicated with and we get a response from them right away, let's just get it done. Just get it fixed. If there's some type of tracking for activity, we can refer to the user story that was related to the issue, or in the release. There's usually release notes. You put that in. But if you want to put it in bug tracking, that's great. But it's not really that big of a deal. Just get it fixed. We found it before it went to production. If they say no to both of those questions, no, it won't block a user story, it won't block the release, then I ask them to please submit a user story. This is a feature change. At one point in time, whenever that was, the current build of this software that's in production was accepted. We said, as whoever that person was or as a group, we said, that's good enough to be our product. It's not perfect, but that is our product now. And we put it out there. Now, our product includes these features that may not be exactly like we originally required them, but we got them good enough to go to production and to be used by our customers. So that now is our product. Any change to that product now would be a feature change. Again, unless it blocks a user story or blocks release of the product, it's just a feature change. The other defect, of course, is if you get a report from production that something is wrong. But again, I still would run those 2 questions by it before I treated it like internally, like something we need to track, like a defect. If it was reported in a ticketing system, it's reported there and it's an indication that something went wrong. We can track that. We don't have to have a second duplicate system of tracking for this issue. It's there in the ticketing system. And when we go to fix it, we can put the user story number, the feature number, if we're able to handle it like a feature. But if that issue that came from production was one that, if it were to happen internally, it would have blocked a user story or it would have blocked release of the product, then yeah, let's get it in the defect tracking system internally, get it addressed, get it fixed, and get it out. I also wouldn't fold those into the user story backlog. Use some way to separate defects from user stories and committed time. These are like hot fixes. They're production support type things. They should be anyway. If it's a defect that needed to be fixed right away, let's fix it right away. Let's not play around with, let's delay it to some other time. So I went very long on the definition of a defect, but it's a massive, massive time sink for the company. You get almost no benefit from it whatsoever, tracking all those issues and defects that were discovered. So I just say, let's not do it. It's not adding to the quality. It's actually costing us so much. It makes it hard to do a quality job. The last thing would be expectation of test results. Far too often when we run a suite of tests in automation or manually, we already expect some of those tests to fail. We already expect it. And when they do fail, we spend hours, countless hours, investigating, troubleshooting, trying to figure out which of the failures are legitimate, where we've got a system issue we need to get fixed, which are because the test didn't get updated, and which are because the test data was out of sync with the testing. That's a big time sink. And it's all because we expect tests to fail. The only reason we expect tests to fail is we haven't done the due diligence up front to make sure everything could be expected to pass. So I encourage you to set the expectation. All tests pass every time in every environment for every build. Now, it sounds like something that isn't achievable. It is, but it takes doing the quality job up front. You say, well, that's going to take a lot of time up front. You're right, but it's going to eliminate exponentially a much bigger amount of time afterwards. If you get that taken care of, we don't have all that troubleshooting. How can you set that, Craig? Well, why is the test there in the first place? If you don't expect your test to pass, why are you even writing the test? Why waste your time? Just don't do the testing. But if you're going to write a test, you should expect that to pass every time, regardless. So that's my encouragement, to set that standard. Will it take a while to get there? Yes. And are there some mechanics and some tooling, some things like that to put in place? Not so much tooling, but approaches to put in place to make that happen? Yes. But just set that standard. Your teams will discover and figure out how to get there. Okay. Along with that, though, little side note, no disabled tests and no short-circuited tests, period. None. Every test is executable. Every test is expected to pass. Okay. So that's my approach. Makes it very easy. If there's a failure, everybody stops. Let's get it fixed and move on from that. All right. So now to the original question.